All right, so this is the key to version 1 of the quiz that you just took. And there are two problems, and in both of these, you had to solve quadratic equations. Now, the first equation looks differently than the second equation, even though they're both quadratic equations. So we're going to solve each one of these differently because the way I wanted you to solve number 2 was to use the square root property. That's the way you had to do number 2. That was in the directions. But in number 1, we're going to go ahead and solve this one using the quadratic formula. See, they both look different. This one here, you'll notice that you have the variable expression that's in parentheses and is being squared. So at the end, it will be a lot quicker just to go ahead and take the square root of both sides to get rid of that exponent 2. So that's why we're going to use the square root property here. Over here, let's go ahead and use the quadratic formula to solve this quadratic equation using the quadratic formula. You have to write this in standard form, meaning that you need 0 on the other side. And so let's go ahead and do this. I'm going to bring the 3 to the left-hand side, and when I do that, you're going to end up with an equivalent quadratic equation that looks like this. Okay, now, the quadratic formula, remember, is this. I'm going to go ahead and write it here. So it's the opposite of b plus or minus the square root of b squared minus 4ac. So b squared minus 4ac is under the square root symbol. So in the quadratic formula, this is referred to as the discriminant. In general, the expression that's under the square root symbol or the radical symbol is the radicand. And all that is being divided by 2a. Now the values of a, b, and c come from these coefficients and constants here. So a, and it's a good idea to determine what that is, a is going to be the coefficient of x squared always. And make sure it's in descending order so it will help you. And the coefficient of x squared is 4. b is a coefficient of x, which is a negative 6. So even though this says subtract 6, remember subtraction you can always change to an addition problem by adding the opposite. So you could say add a negative 6. So the coefficient of x is a negative 6. And c is your constant, the same thing, it's a negative 3. And so we're going to take these values of a, b, and c, substitute into the quadratic formula, and I'm going to get x equal the opposite of b. Well, b is a negative 6. The opposite of a negative 6 is a positive 6. Plus or minus the square root of, and b, I'm going to put that in parentheses. We talked about how important that is to put b in parentheses, especially if b is negative. Because if you don't put in parentheses and you're using your calculator, then you're going to get a negative 36. And remember, b squared should never be negative. Whenever you square a number, it's either positive or 0. It's never negative. Minus 4 times a is 4, times c, which is a negative 3. All of that's being divided by 2 times a, which is 4. So you had to show this step. Then you have to show the next step, which is where you simplify this radicand or this discriminant. So you would say something like this: 6 plus or minus the square root of negative 6 times itself is a positive 36. A negative 4 times a negative 3, and use your calculator if you have to. So basically you're saying, let me go ahead and move this over. So you're saying negative 4 times a negative, remember your negative button's down here, negative 3, and that's going to be a positive 48. So you're going to say 36 plus 48. All that's being divided by 2 times 4, which is 8. Then 36 plus 48, so we're still simplifying the radicand. So 48 plus 36 equals 84. All divided by 8. Now remember, you need to simplify the radical whenever possible. So let's think about the square root of 84. So I'm going to go ahead and do it down here. So the square root of 84, we're asking ourselves, besides the perfect square 1, besides the factor 1, is there another perfect square that goes in 84? So for example, remember your perfect squares are 1, 4, 9, 16, 25, and so on. So one which is a perfect square, will go into all of these numbers. But let's think about 4. Let's look at 4. And you always want to try and determine the largest if possible. So we're going to say 84 divided by 4. And let's see if that's going to be a whole number. And it is. And 21, the only factors of 21 are 1, 3, and 7. Right? And none of those are perfect squares. So then we found the largest perfect square that goes in 84, and that's 4. So then we're going to remember is that, well, since 81 is divisible by 4, I can rewrite 84 rather is divisible by 4. I can write that as a square root of 4 times the square root of this 21. And then the square root of 4 is a perfect square, so that's going to be 2 square root of 21, and I cannot simplify the square root of 21 any further. So I'm going to rewrite this as 2 square root of 21. So this becomes 6 plus or minus 2 square root of 21, all divided by 8. All right, so you had to simplify the radicals. Now what you want to recognize is, hey, I can simplify, see this 6, this 2, and this 8? All those are even. They're divisible by, in this case, 2. And so let's go ahead and simplify this. So this is going to be 6 divided by 2 is 3. Plus or minus 1 divided by 2 is 1. 1 times the square root of 21 is the square root of 21. And 8 divided by 2 is 4. And so we have these two solutions. Now keep in mind that see the square root of 21, that's an irrational number. So that makes this whole solution irrational. And so if you want to, you can leave it like this, or you can say, you can write it as two separate solutions. You could say 3 plus the square root of 21 divided by 4, comma, 3 minus the square root of 21 divided by 4. All right, so that was the work you had to show for number 1. All right, number 2, we're going to do this one using the square root property. Now, to use the square root property, you have to get this variable expression being squared by itself. So I need to get 6 to the other side. So I'm going to subtract 6 from both sides. And when I do that, I'm going to get 5x plus 3 squared. This is 0 right here. And positive 6 and negative 6 is 0. Equal, and then negative 6 and negative 2 is a negative 8. Now at that point, I have to isolate this variable expression, so I need to get rid of the squaring operation. I'm going to go ahead and rewrite this over. And remember, the opposite of squaring is to take the square root, but what you do to one side, you have to do to the other. And remember, whenever you take the even root of both sides of an equation, you have to consider that plus or minus part. And so the square root and the square root undo each other, so you're left with this this variable expression, 5x plus 3, equal, and then plus or minus the square root of a negative 8. All right, now, before we go any further, remember you have to simplify the radicals whenever possible. So let's think about the square root of a negative 8. We learned about the fact that the square root of a negative 1 is defined to be I. And so therefore the square root of a negative 8 would be the square root of a negative 1 times the square root of 8. But remember also, we know that 8, there's a perfect square that goes into 8. In fact, the largest one is 4. So this becomes the square root of a negative 1 times the square root of 4 times the square root of 2, because 4 times 2 is 8. And then the square root of 4 is 2. This is I. So that's I times 2 times the square root of 2. And so I'm going to write this as 2I square root of 2. So that goes here. So this becomes 5x plus 3 equals plus or minus 2I square root of 2. And then all you do is just subtract 3 from both sides, get x by itself, combine like terms, positive 3 and negative 3 is 0. So I get 5x equal, now be careful, these are not like terms, so you have to write it like this, negative 3 plus or minus 2I square root of 2. And then the last step is to get x by itself, so you're going to multiply, since you're multiplying by 5, the opposite is divide both sides like this by that coefficient. And so therefore, I'm going to go ahead and write that here, therefore the solution is going to be x equal negative 3 plus or minus 2I square root of 2 all divided by 5. All right, so that was the solution there. And remember right here where we had 6, 2, and 8 and they were all divisible by 2, we could simplify. We can't do that here. Negative 3, 2, and 5, the greatest common factor there is 1. And so that's it. So that is the key to version number 1.